Hello everyone, welcome to today's lesson. So as we are continuing with domain and range of a function, so here we have another other few sums from domain and range. The first sum for today that we'll be solving would be find the domain and range of fx equals to under root 5 minus x. Okay, so few things that I'll revise before going into the domain is I just need to check whether the function will be undefined for any values of x or not. If the function is defined for all values of x, then the domain will become all real number. You are already aware of it, isn't it? But if any value of x makes the function undefined, then we need to delete those, or we need to remove those values of x. Okay, so there are only two conditions in mathematics that is not accepted, that is something divided by 0, and number two, a negative number inside the square root. These two conditions are not accepted, and let's say we call this condition as bad conditions. Okay, so these two conditions are very bad for calculating domain. Okay, so let's see in this particular sum. So I'll write it down here. For domain, if any of these two conditions will be you may say will happen in this following function. So the function is fx equals to 1 by root 5 minus x. Clearly you can see there is a square root of 5 minus x in the denominator, isn't it? So I think both the conditions will occur in this following function, because the function is in the denominator as well as it is inside the square root. So for a domain, 5 minus x has to be greater than equals to 0. That's the actual condition, isn't it? Because the number inside the square root should not be negative. The number inside the square root should not be negative means, let me write here, not negative. Negative means positive or 0. Both are accepted, isn't it? It should not be negative means either it can be positive or 0. But since the function is in the denominator, check it out, it is in the denominator, that's why we cannot accept 0 as well, because the denominator becomes 0, then the square root of 0 is a 0, which becomes anything divided by 0, which is undefined, isn't it? So now I'm going to rub out this condition as well. So equals to 0 is also not accepted because it is in the denominator. So clearly we see for domain, 5 minus x has to be only greater than 0, though equals to 0 is also accepted inside the square root, but it is in the denominator, that's why we exclude that. Got it? So from here we get 5 greater than x. So therefore domain is I'll write it down, x is less than 5. Less than 5 would mean minus infinity to 5 and an open bracket both the sides. So did you understand? So that's the domain of this following function. So I hope you have understood this. Very easy and clear idea of calculating domain. Now let's go to range. Okay, now comes range. Now for range, let me write down, there are two techniques, you know it. I think I'll follow the technique wherein we have to change the subject of the formula. Let me write, let y equals to 1 divided by under root 5 minus x. Correct, everyone? Check this out. 1 divided by root 5 minus x. That's the function. Now there are many conditions we need to check for a range. Okay, first of all, number one, we need to change the subject. Let me write down, change the subject. I'll change the subject of the formula. Number two, I'll have to check whether it will be something divided by 0 or a negative number inside the square root, whether it will be undefined for any values of y. Okay, then the third thing we have to check is the domain restriction, whether if there is any domain restriction. Okay, and then finally number fourth, we have to check whether it is a positive square root, positive or negative square root. So I need to check the question as well. Okay, so these four conditions keep in mind. I'll do it accordingly. Okay, so let's flip the function first of all. So I'll write y square equals to 1 divided by 5 minus x. I think that should be accepted, squaring both sides. That gives me now 5 minus x equals to 1 divided by y square, and then I'll get a 5 minus 1 by y square equals to x. Got it? So that's what we will get. Now if you want to take LCM, it's okay. If you don't want to take LCM, it's fine, not a problem for me. So now what we need to do is, now clearly it is saying clearly, now I need to check whether this function can be undefined at some point, isn't it? Okay, let me do like this. Let me say that, let me take LCM. Y square, 5y square minus 1 equals to x. Okay, so is there any number which will make this function, the highlighted function, undefined or undefined? Yeah, obviously undefined. So obviously there is a y square denominator, so that means if y becomes 0, then this can be, you may say this will be undefined, isn't it? So I'll write here, comma, y should not be equals to 0. Remember that y is not allowed to be 0, because 0 makes this function undefined, okay? And there is no square root, so no worries for that. Is there any domain restriction? Clearly there is a domain restriction. The domain restriction is x has to be greater than 5, isn't it? So less than 5, sorry, x has to be less than 5. So I'll write it down here. So from domain, let me write it down. X is less than 5, so that means I'll have to do 5 minus 1 by y square is less than 5. Can I do that? Yes. So that gives me 5 minus 5 is less than 1 by y square. Okay, I've used this upper one rather than using the lower one actually. Okay, you can use the lower one as well, no problem with that. So 0 is less than 1 by y square, correct? And then now this is interesting. What happens is if I take it this side, then I'm getting 0 equals to is less than 1. That's obvious fact, isn't it? That is not going to happen, obviously. Okay, then let me change this a little then, if that is the case. Let me use the highlighted function only. So 5y square minus 1 by y square is less than 5. So 5y square minus 1 is less than 5y square. Now that gives me okay, sorry, even the previous one would be accepted. What was the previous one? 5 minus 1 by y square is less than 5. Then 5 minus 5 is less than 1 by y square. Let me just tell you this. 0 is less than 1 by y square. Then 0 is less than 1, which is true. I'll just write it down, which is true. It's obvious fact, isn't it, everyone? 0 is less than 1, because if we crisscross, even if you use the other one, I'll do both the ways. 5y square minus 1 y square less than 5, 5y square minus 1 less than 5y square, then 0 less than 1. So which is true, again, which is true. You can do any one of these, okay? Both are same actually. Okay, if that is the case, then obviously it seems that as if y takes all real numbers, because even with the restrictions, whatever be the value of y, it's always gonna be, you may say it's always going to be 0 will always be less than 1, isn't it? Whatever value of y I put here. Okay, so it accepts all real numbers, but we need to check the so subject changed, this condition done, domain restriction done, but we need to check the question always whether the function is a positive or negative square root. Clearly, we'll write here, clearly y is the positive square root of 1 by under root 5 minus x, isn't it? Therefore y will be greater than 0. Okay, greater than equals to 0. It should be y should be greater than equals to 0, but it can't be equals to 0 from the previous conditions. So therefore what will be the range, everyone? Range will be, let me write it down here, range will be sorry, not open, but open here, 0 to infinity, like this. Okay, again I repeat, so I think there is a little confusion here. Okay, from the domain we had the condition that x has to be less than 5. Using that condition I get an obvious condition where 0 is less than 1, which is true. So whatever be the values of x, y, 0 will be less than 1, isn't it? Even on the other way I have done it, using the upper and the lower function, it's the same working actually. I get 0 is less than 1. That means it seems as if all values of y is accepted, but clearly I know y can't be 0. That's one condition, keep in mind. Okay, the other thing, y is a positive square root of 5 minus x, 1 by root of 5 minus x. That says that will prove that y has to be greater than y has to be a positive number. So y has to be a positive number and y can't be 0. So clearly y is greater than 0. So that's why we got the range 0 to infinity. Got it? So this is how we solve this particular sum. Okay, here we have the other one, second one, fx equals to x minus 3 divided by 2x plus 1, and the question would be find the domain and range. Domain and range. Okay, so again the way we proceed would be the same. So for domain we need to check if there is any number which would make this function undefined. Okay, for domain you clearly know whether it there occurs one of these two situations, something that 0 in the denominator or a negative number inside the square root. I clearly see that there is 2x plus 1 in the denominator, so I write for domain 2x plus 1 should not be equals to 0, isn't it? So 2x should not be equals to -1 or x should not be equals to -half. So clearly -half will make this function undefined. So thus what will be the domain, everyone? Domain would be I'll write down all the real numbers except -half. Clearly got it? Okay. Now for range there's something interesting. Let me do it here itself. For range, as you all know, we proceed with the technique where we change the subject of the formula. So for range we write let y equals to x minus 3 divided by 2x plus 1. Correct? So let's change the subject of the formula. 2xy, if you multiply, plus y, if this goes up here, equals to x minus 3. That way I'll have to make x as the subject. So 2xy, sorry, not this particular way. So okay, y plus 3, I can bring it that side, x minus 2xy. That would be better. Now y plus 3, look at it carefully, x common, 1 minus 2y. Can I do that? Yes, I'll do it in the next page now. Y plus 3, do it here, y plus 3 divided by, clearly, what do you have here? Divided by 1 minus 2y. 1 minus 2y equals to x. Okay, so here again I clearly see 1 minus 2y should not be equals to 0, isn't it? That gives me 1 should not be equals to 2y. That gives me half should not be equals to y. So again here as well, y should not be equals to half, isn't it? Is there any other condition? Is there any other you may say situation wherein y can become undefined? Absolutely no, because there were only two such cases, a negative number inside square root or a 0 in the denominator. So clearly we take the first condition, 1 minus 2y can become 0 when y equals to half. So that's why we omitted y equals to half. So the range will now become therefore the range, or I can say not the range actually, therefore I may just say y belongs to all the real number except half. Can I say that? Not the range. Okay, so check this out again, I repeat. So I hope you've understood. Just check it out from here. What did I do? I flipped the formula, I changed the subject, I made x as the subject by taking common, and then I get to this expression here, y plus 3 divided by 1 minus 2y. 1 minus 2y can become 0 when y equals to half. That's why I omitted half out of the real number. Now the question is, the domain is, check this out, I'll write down here, domain is all the real number except minus half, and the range we are about yet to know, isn't it? And clearly the range, it is suggesting us that the range is all the real number except half. But what are the chances that, okay, or you may say what if some values of y apart from r minus half will make it equals to minus half, isn't it? Check this out, this is a very important question. I am saying, what if I'll put some other values of y and then x becomes minus half? X is not allowed to become minus half, isn't it? Clearly the domain says x cannot be minus half, because minus half will make the denominator 0. So my question is, what is the guarantee that when you put all the values except half, the value of x will not come minus half, isn't it? That we have to justify. So for that, what we are going to do is, at the side here, let y plus 3 divided by 1 minus 2y, when you put some values of y which we are not aware of right now, then it becomes minus half. Let's say, let us try to prove that it is equals to what, everyone? Minus half. Let us say when I put the value of y, some real values of y, the answer of this particular fraction becomes minus half. That is, x will become minus half, which should not happen actually, isn't it? In that case, y plus 3, in that case I can say 2y plus 6 equals to minus 1 plus 2y, isn't it? 2y and 2y gets cancelled, 6 equals to minus 1, isn't it? So I'm getting 6 equals to minus 1, which is absurd. That means in any situation, this is not going to happen, because if y plus 3 divided by 1 minus 2y has to become minus half, then the number system has to change and 6 has to be equals to minus 1, which is not possible, because 6 is not equals to minus 1, isn't it? So that's why there is no such number which can ever make this particular fraction, the highlighted fraction you can see here, this particular fraction or the value of x equals to minus half. So now therefore we can just conclude, therefore a range is how much? range will be all the real numbers except half. Okay, half is not allowed. Why? Because if you put half, the denominator will become 0. So we got the domain and the range for this particular sum. So you can go through it one more time. Okay, so this was comparatively easier. I hope you have understood this. Okay, the third and the final sum that we have for today is fx equals to x square minus 4. So this would be a little tricky now. Check this out. The question is find domain and range again. Find domain as well as range and range. Okay, so to find domain, I need to check whether one of these conditions will arise, that's a negative number inside the square root or a 0 in the denominator. Clearly, I think the first will be rejected. I think the second, there is a strong chance that the second one will happen. So therefore, for domain, I'll write for domain, the number that is x squared minus 4 inside the square root should be greater than as well as equals to 0, isn't it? You know how to simplify these type of equations. We have done it in last classes. So I'll factorize it, a plus b, a minus b. Okay, and then I'll get greater than equals to 0. Okay, then had it been an equation, the checkpoints would be minus 2 and 2, isn't it? We have done this earlier as well. So I need to check the left, right and the center by putting a test values. Let's try with first left means minus 3 square 9 minus 4, that will be positive. In the right in the middle, if I put 0, it will be negative, and here it will be positive. But according to the equation, I want greater than equals to 0. So therefore x belongs to, you may say, minus 2 to 2 box bracket. Thus what will be the domain? Domain will be all those numbers between minus 2 and 2. So did you understand? That's how we solve the first part of the equation. Okay, first part of the question, the domain part. Now let's work with the range part. So for range, I'll do it side by side. For range, let me reposition this a little. Okay, for range, let us suppose y equals to under root x square minus 4. If I square it, you'll get y square equals to x square minus 4. And if I realign, you will get, if I transpose, I'll get this one. And then again, you are getting exactly the same as you've got it here, isn't it? So again, so therefore y square minus 4 has to be greater than equals to 0. You are already aware of that, isn't it? So y plus 2, y minus 2, again same equation, we are getting greater than equals to 0. And if you make a number line, again you will get exactly the same, because this number line is also exactly the same that we have done it earlier. The factors are also same. So here positive, negative and positive. But according to the question, what do you want? You want positive. So y belongs to, you may say, minus infinity to minus 2, and then again box, there has to be a box bracket, and then union 2 to infinity, isn't it? But let us check the question one more time. So let me write with a different color. But y is the positive square root of under root x square minus 4, isn't it? We have to check the question also. Check this out. Y is the positive square root, so negative ones will be rejected, this one. So what is the answer? Therefore y range will be you may say 2 to infinity. Okay, in this case. So because we can't take the negative square roots, we just have to take the positive ones only. So the values of y can't be negative. We'll only accept the positive ones, isn't it? So that's why we'll take 2 to infinity. So is that clear? So that's all for today. So you've already copied these 3 sums. Just watch the video and try to understand the reason behind calculating, or the process of calculating, the domain and range. Thank you.